Okay, here we're being asked to find the derivative of this function and evaluate that derivative at x equals pi over 4. And that function, of course, is a composite function, which is going to require the chain rule. So let's use Leibniz notation here. Remember, that is L-E-I-B-N-I-Z. He's a famous German philosopher and mathematician. And this is the notation he opted to use with derivatives. So dy over dx is going to be the derivative of the outer function, which is the derivative of the natural log, multiplied by the derivative of the inner function, which is cos of x. And in case you can't remember how to differentiate natural log of x, remember we looked at that via first principles, and lo and behold, all we had to do is take the reciprocal of our x. Another way of looking at that is the derivative of ln of x is the reciprocal of the input, which will probably help us here in this situation. So the derivative of this function is going to be the derivative of ln with cos of x still trapped inside. And again, another way of interpreting that is it's the derivative of ln is always the reciprocal of the input, which of course in this case is cos of x. And finish off our chain rule here. Multiply this by the derivative of that inside function, cos of x. I guess it's not terribly tragic, but our colors are a little off here. I've been reserving orange for the chain rule for whatever reason. We'll keep our theme alive. There we go. So 1 over that input, derivative of the ln first multiplied by the derivative of the cosine. So our dy dx is going to be 1 over, one color will suffice from here on out, I'm sure. Derivative of cos of x, remember, is a negative sign. So we have minus sine over cosine, which I'm sure you'll recognize as a tangent. Don't forget the negative. Sine over cos is tangent. So now I can evaluate that expression at x equals pi over 4, which is all that that notation means, which is going to be minus tan of pi over 4 radians. Remember, your angles always have to be in radians in calculus because that's where we got our derivatives from, utilizing radians. So our expression here is going to be minus tan of pi over 4, which of course is equal to -1.